Hi students, welcome in chemistry classes. I am Priyanka Jain and you are watching videos of thermodynamics. In our last lecture we have studied about entropy and we have seen various type of formulas that are used for the entropy change. Okay, now we will see some of the numericals, how we have to apply these formulas when we are doing the numericals. Okay, so see here, first question. For an ideal gas, CPm is equal to 5 by 2R. Calculate the change in entropy suffered by 3 moles of gas on being heated from 300 Kelvin to 600 Kelvin at A constant pressure and B at constant volume. Okay, so we have given that CPm is equal to 5 by 2 R. Okay, and we have given the value of N is equal to 3 mole. Okay, temperature we have given T1 is equal to 300 and T2 is equal to 600 Kelvin. Okay, these things we have given. Now firstly we have to find out the del S at constant pressure. For this what you have to use? We have used the formula del S is equal to N CPm natural log of T2 upon T1. Okay, so put here 3 moles. Okay, always use the units. Okay, so CPm 5 by 2R into R's value is 8.314 joule per Kelvin per mole, right? Okay, then you have given natural log, so you will have to use 2.303 logarithm of 600 Kelvin upon 300 Kelvin. Now you can use the calculator, you will get your answer. You will get 43.22 joules per Kelvin. Okay. Now see the next. You have given at constant volume. So what will be your formula? Your formula will be del SV at constant volume. It means N CVM natural log of T2 upon T1. Okay. So just you have to put here values 3 moles. Then see here, you have given CVM and you know that CV will be equal to Cp minus R. Okay, so you will get it will be equal to 3 by 2 R. Okay, so here we can put 3 by 2 into value of R 8.314 joule per Kelvin per mole into 2.303 logarithm of 600 Kelvin upon 300 Kelvin. Okay, so when you are solving it, you will get your answer 25.93 joule per Kelvin. Okay, so this will be your answer. Okay, now see the next question. See here, in this question you have given calculate del S for 3 moles of a diatomic ideal gas which is heated and compressed from 298 Kelvin and 1 bar to 398 Kelvin and 5 bar. We have given CPM is equal to 7 by 2 R. Okay, so you have given that temperature T1 is equal to 298 Kelvin and T2 is 398 Kelvin. Okay, pressure P1 is equal to 1 bar and P2 is 5 bar. Okay, N's value is 3 and CPM you have given 7 by 2 R. Now you have to use the formula, the general formula for the entropy change, and CPm natural log of T2 by T1 plus R natural log of P1 by P2. Now just you have to put the values. So del S will be equal to N's value is 3 mole. Okay, and CPM you have given 7 by 2 R. It means 7 by 2 into 8.314 joule per Kelvin per mole into 2.303 logarithm of T2 by T1. It means 398 Kelvin divided by 298 Kelvin. Okay, plus you have to do R 8.314 joule per Kelvin per mole. Okay, 2.303 natural log of P1 upon P2, and P1 is 1 bar divided by P2 is 5 bar. Okay, now you can solve this. So you will get 3 into 8.422 joule per Kelvin minus 13.383 joule per Kelvin. Okay, so your answer will be negative minus 14.833 joule per Kelvin. This will be your entropy change. Okay, let's see the next question. See here this question. By how much does the entropy of 3 moles of an ideal gas change in going from a pressure of 2 bar to a pressure of 1 bar without any change of temperature? Okay, so what formula you have to use? There is no change of temperature. Okay, so what you will have to use? Del S is equal to NR natural log of P1 upon P2. Okay, so N is equal to 3 moles. Okay, value of R, you know, value of R is 8.314 joule per Kelvin per mole into 2.303 natural log of 2 bar upon 1 bar. Okay, so what you are getting, this will be equal to 17.29 joule per Kelvin. Okay, this will be your answer. Let's see the next question. See here, this question. Calculate the entropy change at 373 Kelvin for the transformation. What is the transformation? H2O liquid is changing to H2O gas from 1.01325 bar to 0.101325 bar. And we have given del H of vaporization is 40.668 kilojoule per mole. So in this transformation, two steps are proceeding. Firstly, H2O liquid 1.01325 bar is this pressure. Okay, this is changing to H2O gas at 1.01325 bar. Okay, then this H2O gas is changing to H2O gas at 0.101325 bar. It means firstly the liquid form is changing to gas. Okay, it means there is phase transformation. And secondly, there is no phase transformation. The gas is changing to gas, only the pressure is changing. Pressure is changing from 1.01325 bar to 0.101325 bar. Okay, so first of all we will have to see this del S1, and then we have to see del S2, and then we have to plus both of them. Okay, so see, for del S1, what formula you have to use? You will have to use del H vaporization divided by temperature. It means 40.668 kilojoule per mole. This is given to us in kilojoule. Okay, so you will have to multiply it with 1000. Then divide it by 373. Okay, so your answer will be 109.03 joule per Kelvin per mole. Okay, now you have to find out del S2. Del S2 you will have given by R natural log of P1 upon P2. It means 8.314 joule per Kelvin per mole. This is the value of R. Then 2.303. Okay, then log of P1 upon P2. It means P1 is 1.01325 bar. Okay, and P2 is 0.101325 bar. So now you can calculate this. This will be equal to 19.15 joule per Kelvin per mole. Now, the total entropy change, del S will be given by summation of this del S1 plus del S2. It means this will be equal to 109.03 plus 19.15 joule per Kelvin per mole. Okay, so your answer will be 128.818 joule per Kelvin per mole. Okay, this will be your answer. Okay, so in this way you have to do this question. Now see the next question. See here, you have given 10 gram of ice is heated to become vapor at 373 Kelvin and 101.325 kilopascal. Calculate del S for system. You have given del S fusion of ice at 273 Kelvin is equal to 334.72 joule per gram. Del S vaporization of water is 373 Kelvin is 2259.36 joule per gram, and average specific heat capacity of liquid water is 4.184 joule per Kelvin per gram. Okay, so now see here for total entropy change. Firstly, see the transformation which is happening. We have given 10 grams of ice. Okay, 10 gram of ice is heated. It means 10 gram H2O we have given, that is solid. Okay, it is at the temperature 273 Kelvin. Okay, and the pressure is 101.325 kilopascal. Then it is changing to 10 grams of H2O at liquid state. Okay, it is changing to liquid state. It means water is changing from solid to liquid state at 273 Kelvin and 101.325 kilopascal. Okay, then it is changing to 10 gram of H2O liquid. Now it is changing to 373 Kelvin. Temperature is changing. Okay, pressure is same 101.325 kilopascal. Okay, and then it is changing to 10 grams of water at gaseous state. It means it is changing to vapor. Now the temperature is 373 Kelvin. Okay, and pressure is 101.325. Okay, so see here, first change is here. So this is del S1, second here del S2, third here del S3. Okay, so first of all we have to calculate del S1. In this process you can see that the temperature is same and pressure is same. Only the state is changing from solid to liquid. It means here we have to use the formula del S1 is equal to del H of solid is changing to liquid. So it will be del H of fusion divided by T. Okay. So this will be equal to 334.72 joule per gram divided by 273 Kelvin. This will be equal to 1.226 joule per gram per Kelvin. Okay. Similarly, you have to find out del S2. In this process, you can see liquid is same. There is no phase transformation. There is liquid. This is liquid. No phase transformation. Only temperature is changing from 273 to 373 Kelvin. It means we will have to use the formula Cp, natural log of T2 upon T1. Cp you have given 4.184 joule per Kelvin per gram and natural log of 373 Kelvin divided by 273 Kelvin. Okay, so this will be equal to 1.3058 joule per Kelvin per gram. Okay, third thing you have to find out del S3. This will be see here. Del S3 means liquid is changing to gas. Liquid water is changing to gas. Temperature is same, pressure is same. Liquid is changing to gas. It means del S3 will be equal to del H of vaporization divided by T. It means 2259. 0.36 joule per gram divided by 373 Kelvin. So this will be equal to 6.057 joule per gram per Kelvin. Okay. Now you have to find out del S, total del S. Okay. So this will be equal to del S is equal to del S1 plus del S2 plus del S3. So this will be equal to, you can calculate 1.226 plus 1.3058 plus 6.057. This will be equal to 8.588 joule per Kelvin per gram. For one thing you should remember, this del S is for 1 gram of water. Okay, and you have to find out for 10 gram of water. You have given in the question paper 10 gram. Okay, so del S for 10 gram water will be equal to, multiply it with 10, 10 into 8.588. This will be equal to 85.888 joule per Kelvin. Okay, this will be your answer. Okay, so you can see here 2 to 3 formulas are basically asked. Okay, and these simple formulas just you have to apply, just you have to remember the units. Unit change is very much important. Okay, so just keep remember what is asked to you. You have given ideal gas or real gas, and then which thing you have asked, temperature is constant or pressure is constant or the phase is transforming. Okay, then you can apply the given formulas and just you have to put the values, you will get your answer. Okay, so if you are getting any problem in any question, you can comment, you can give me the question, I will give you the answer. Okay, so I think you will like this video. Okay, if you are liking, then please share these videos, subscribe the channel and like and comment. Thank you.